Hi, good morning or good afternoon, depending on where you are. You've reached VFS Tech Talk on PEO Aviation's electrical power systems. I'm Bill McCandless out of the Redstone chapter. We're going to hold for a minute or two while we let others log on, but we're with you and we'll be talking here shortly. Thanks. Okay, I think we're going to get started with a couple housekeeping notes. Like I said, I'm Bill McCandless. I'm the Vice President of the Redstone chapter, and you're in a Tech Talk series that's co-hosted by Redstone chapter, by Arizona chapter, and Philadelphia chapter. So we're going to do a couple announcements for each chapter, and then we'll get into introducing our guest speaker, Mr. Matt Sipe. So from the Redstone side, we've just now started doing these virtual presentations instead of the hosted live events. We see that continuing at least for the next couple months. We've had good turnout for the tech brief last month hosted by Arizona, and we'll continue that. We are looking at a potential virtual and in-person technical conference on complex systems. We're working those call for papers now and working the issues with National to figure out how we're going to do that with a joint in-person and technical program. I know everyone's just fresh off a forum, and I hope that people had a chance to enjoy all the content that was available, even though they may or may not have been able to attend in person. I'm going to throw the mic over to Colton in Arizona, and he's got a few comments out of Arizona. Colton.
All right, good morning and good afternoon, everybody. My name is Colton Marchessault. I'm the program director for the Arizona chapter of Vertical Flight Society. So just a couple of quick announcements about what we have upcoming and going on. Eventually, we will be getting into our eVTOL AVTOL conference coming up in January of 2021, and we are supporting headquarters on that. So doing a lot of work locally for that guy. And really the only kind of upcoming event I suppose that we have is we're working with the Philadelphia chapter on their next virtual presentation that we'll have, working with Columbia Helicopters. That should take place about mid-November. So be on the lookout for an announcement for that guy. And I think for now that's all we got. So I'll turn it back over to you, Bill.
Okay. Do we have anyone on from Philly chapter? They need a minute. Okay, you'll have to unmute if that's the case. Okay, so just as we get into the presentation, there's a chat window available in your web application. I'd like to post questions in the chat window, and then I'll ask those to Matt, and then we can engage in discussion at the end of the brief. I'd like to move forward and introduce our speaker, Mr. Matt Sipe. He's the chief of the Technical Management Division of Aviation Turbine Engines Project Office and Army's PEO Aviation here in Huntsville. He's responsible for providing overall direction, coordination, leadership management for all engineering functions for the improved turbine engine ITE, T700 and T55 engine products and electrical power systems. Matt's been in a couple of different program offices here in his recent past, both IT and future vertical lift. Temporarily served as the IT Tech Chief, the Future Vertical Lift Tech Chief, and as well as the Mission Systems Architecture Lead for FVL. Looking at our big push for open systems architecture concepts. Matt's also been in the Apache Project Office as the Lead System Engineer, And then I knew Matt back in the Aviation Engineering Directorate, now called System Readiness Directorate, as part of CCDC here in Huntsville. And he worked MH60 platform issues. He's been an executive officer for our directorate at AED, and a platform engineer, and worked other FMS issues. Okay. And then Matt, in a previous life, I guess, Matt, lastly, in the U.S. Air Force, he served as an active duty officer, providing program management and engineering expertise for Special Ops C-130 program office, to lead trainer and evaluator in aircraft battle damage. So Matt's degrees are from aerospace engineering from University of Alabama, Bachelor of Arts degree from theology from Life Christian University, and master's degree in management and leadership from Webster. Okay, Matt, I'll hand it over to you. Welcome and thank you. And then again, if we'll just populate questions in the chat, we'll have time to talk at the end. Thanks.
Good afternoon, and certainly thanks to VFS for hosting this event and certainly providing me an opportunity to discuss this topic of electrical power systems. It's a relatively new topic within PEO Aviation. So again, this is Matt Sipe, and as Bill said, I serve as the technical chief for the Aviation Turbine Engines Project Office. Our mission is really to essentially manage the Army's rotary wing turbine engines, and now also electrical power capabilities by designing, developing, delivering, supporting power systems for U.S. aviation and coalition partners. All right, so I was asked to present to you on EPS, and before we move into the charts, I think it's best if I first define what that encompasses so that we're all kind of operating off that same baseline. And so when I say EPS, what I mean is everything required on a platform to electrically power the aircraft and aircraft systems. And so that would include things like main generators, the APU or an SPU and its generator, power and thermal management systems, then all of the power electronics like converters and circuit breakers and transformers are required to enable all of these systems to operate on the aircraft. Let's go ahead and move to the next slide. So now we'll give you just a little bit of history on how we picked up this area of work. A few years ago, when General Todd was the PEO, he spent the latter part of his tenure really looking forward and trying to position PEO Aviation for success many years down the road. He had our office take a look at really electric hybrid propulsion and also at electrical power systems to see how well we were really positioned for future growth. As a result, myself and a small team of folks spent a lot of time evaluating systems that we have today and doing lots of market research relative to the future of EPS and even electric hybrid propulsion systems. You know, we started to dig into those electrical loads analysis for each of the platforms and started pulling all sorts of RAM data. I went and personally tried to visit every company I could that said that they were doing something novel or innovative with respect to these areas, and then started to project requirements that our platforms may see in the future. And what we found was really pretty interesting. We found that, one, the commercial industry is already on a relatively fast train relative to EPS, and it seems like it really began with, most of you are going to be familiar with the more electric aircraft area that's certainly been a topic within VFS over the past years and has continued. And then also the part of the more new area of eVTOL that I think VFS has really done a great job of educating all of us of what's going on in that industry. But regardless, the industry is clearly dumping tons of money into these areas, and I'll give you some examples of those figures in later slides that you've probably have all seen because I've actually pulled them from VFS presentations. But the point is that the commercial market has been vastly advancing electrical power systems and electric hybrid propulsion tech in a very significant manner over the past decade or two. And so what we found with respect to Army aviation platforms is that we actually have electrical power capability gaps today in our enduring systems. You know, what we found is, our equipment is really circa 1970s and 80s and some even before that. And our platforms really haven't done a great job of keeping those systems modernized because they were still effective. We're still meeting mission. But currently available technology really offers us an opportunity to, really substantially increase performance and even see some cost benefits relative to these systems. And one of those areas I'll quickly point out is just energy storage. we currently use batteries that use tech from the 60s, right? And as a result, several of our platforms actually don't meet current requirements relative to emergency power availability. We also found that from a power availability perspective, we're pretty far behind the power curve based off of what we project are some of the future requirements. That's what this chart is really showing, is that projection. And so for those of you who are familiar with the Atom community, they've gone out there and they've projected that power requirements are going to increase on the order of 3 to 5 times what they are today. And so back to General Todd's question to us is, are we positioned for that? And our quick response was no, we're not. And so all these demands that are causing the need for more power to be there are really driven by technologies. And let's listen just some of them out to the side there. There are things like DVE, advanced survivability equipment, or even directed energy weapons. Those are all going to place significant demands on our antiquated systems. Right, and so as you can see, the future demands will quickly exceed the capability of the platform. And so I certainly took all the numbers out of there, but you can just generally tell it doesn't take many new technologies being added to the aircraft before we get into the red area, and we no longer have the redundancy that we require on our aircraft to perform our missions. And so the gap is there for sure. And so what we need to really do is take a holistic approach to energy storage, power generation, power electronics, power management, and also thermal management. We've got to maximize component and system efficiency. We've got to tap into power potential that already exists on our platforms. We need to migrate to higher voltage DC systems, which we'll talk more about. And we need to get rid of single purpose solutions that really create a lot of dead weight on the aircraft. And a good example of that is just an APU. Right? Today we use an APU to start the aircraft, and then we fly around with 130 pounds or more of dead weight. And so from an aerospace engineering perspective, that makes no sense to me. so we can do better. And so I want to kind of unpack some of that as we go through the rest of the briefing today. So let's go ahead and move on to the next slide. And so this slide is really intended to communicate how EPS modernization ensures the enduring fleet remains relative, especially since FEL procurements are only intended to replace a small portion of our fleet. And so it's not only just the enduring fleet, but there's also future vertical lift aspect of this as well, because both of those certainly matter for future. Both are part of our future. But to stay relative, you really have to continue to increase and provide more capability to the soldier for the entire fleet, not just the FEL fleet. And that will happen through technology insertions. So let me kind of walk you through this chart. There's a lot there. As part of our market research, we not only for new tech, but we're not only looking at new tech, but we're also assessing how we increase capability and still remain affordable. Our market research showed us very clearly that the commercial industry has already begun migrating to higher voltage DC systems, and that's nothing new. They've been doing that for a while, and they continue to project to move to even higher voltages. And what we've seen so far is that there's a pretty heavy expectation from just the market research we've done that FEL is likely going to end up with a 270 volt DC architecture at a minimum. Now, personally, I don't think we'll have to go much higher than 270 volt DC in the near term, simply due to the risk to maintenance personnel as you continue to go some of those higher voltages. So we don't want maintenance personnel to have to go from their current systems to these really high voltage ones over a short period of time, because I think that'll be a pretty unsafe environment for them based on how much we have to do maintenance on these systems. But if we're right, and we do need to go to these higher voltage systems, we should see large parts of industry and FEL while they continue to move to these higher voltage 270 DC systems, we should be able to leverage those activities. Right? It's kind of that problem we've always faced in the military, where we get behind the commercial world, and so we end up paying actually more for older systems. Right? It's kind of like I told somebody the other day, we're talking about TVs, and when the first plasma TV came out, I knew somebody who bought one of those. It was $3,000, right? But Now I can go buy that same TV for like $200, right? And it's even better. Right? So we got to stay on the forefront of some of these technologies to really leverage some of those cost benefits associated with it. But with that said, we also know that there's many of these high energy systems out there, like I was referencing on the earlier chart, that they want high voltage systems. And so that's not an easy solution space for the way we're currently architected on our enduring fleet. And so there's clearly a demand for high voltage systems, and not only are they already present within the commercial industry, but we see that's where future vertical lift is headed. And so what does the enduring fleet do? So that's kind of the problem. The problem is our enduring fleet, we have a lot of big 115 volt AC equipment, whether it be de-ice or all kinds of motors. And this really becomes a problematic scenario for keeping the enduring fleet relative. But the solution is still pretty clear to us. We have to modernize that enduring fleet and not only increase the power available to the aircraft, but also adopt new technologies and start a migration to 270 volt DC. Let's go ahead and move on to that next slide. So what are we doing? And I want to camp out here for a good bit, because I really want everybody to understand what our office is actively engaged in and kind of some of our thought process on this. Again, when we're talking about EPS and doing things like significantly increasing power available or migrating from AC to DC systems and or migrating to higher voltage systems, we've been spending lots of time trying to model and evaluate architectural constraints and solutions. Because again, this is not a real easy solution. I mean, yes, we could just say, hey, we're all going to migrate to 270 volt, but it would cost us a ton to try to do that on one of our enduring fleet platforms. And so, as we all know, you're shrinking budgets, and it just seems like it's tighter and tighter. So we've got to figure out an affordable way to migrate to where we need to be with respect to higher voltage. Say there are also lots of benefits to migrating to higher voltage, that we've got to consider, and some of that's the integration cost, right? That over time, we can leverage things off of FEL, or we can actually incubate technologies for FEL, and so those are all cross-platform things that we've got to be considering and looking at as we develop an architecture solution. So this has really been a critical area for us on informing which systems we need to develop, when we need to develop, which technologies we need to focus on first, and to also inform FEL requirements as well, which we've certainly been doing. So again, we're talking architectural development efforts, and a lot of this is really just about defining requirements for us. What are going to be those requirements that we go after? Because and it's probably a lot of times the first question we get from people is, well, where's your requirement to go do this? At least that's what all of our platform buddies ask us as a PM office. And unfortunately, most of the electrical power stuff, these are all derived requirements. It's not going to come from the end user that gives us a requirement to say, hey, I need, X kVA for the future of this aircraft. These are derived from the types of technologies and that enable capabilities on the aircraft. So lots of work in the architectural development effort. We've done a lot of internal modeling within our teams, and we've also actually gone out into industry and pinged some folks in industry to look at what we've done and also provide a different perspective of that. And I expect that effort to continue over the next couple of years, where we will be very intentional about sharing more and more information with the platform vendors, as well as some of the vendors that are out there that would be in the space of the different electrical power systems themselves. And so that effort will continue. Now, the next line there is increased power storage, or you can also just say energy storage. It's probably more accurate to say that. But our current focus area on this is really just meeting that current emergency power gap that I talked about earlier. And we first started this effort by writing what we believe is the Army's first lithium-ion battery spec. Worked heavily with the Navy, and then also with some folks on the ground side that had written similar specs for lithium-ion batteries, but some of those never got completed or still in work. But but we saw that we had a gap, so we went and wrote a spec and actually used an OTA to get it out there in industry, got some feedback from folks, and then we're in the process right now. We've actually had one kickoff, and we got one more kickoff occurring next month with 2 different vendors. They're working on the development of lithium-ion batteries that will essentially fit in the same size and with the same weight of current aircraft batteries, but provide nearly double the performance. And with that, we recently actually just completed a risk reduction ballistic test on one of these, because we know that if we look back in history, people who've tried to use lithium-ion batteries, they found rather explosive responses with them when they went through a ballistic test event. And so, but we also realized that those were with very early versions of lithium-ion technology. And so the ones we're looking at now are the latest and the greatest. And from what we've seen during at least our risk reduction test, we're not getting the same results that we saw previously. So that's a pretty good indication for us that we're on a good path. I can just tell you before I leave that topic that it seems like the way some of these things are packaged certainly make a big difference, but also what the battery management systems are doing on these energy storage systems is really pretty phenomenal, and how they help control some of those responses that have been seen previously. Right, so the next item on there is increased power generation. I'd say that today each of our platforms barely have enough power generation capability to meet their current requirements. And that's what you saw earlier on that chart. And most of that is really, it's a redundancy requirement. We have to have redundant power. So technically, yes, I can power much more stuff, but then I'll lose my redundancy requirement. But again, we started the same process, started looking at what the specs were that were out there for power generation and generators and whatnot, and found that the last one that was used was from like the 80s. And so we started writing a new spec for that to try to communicate to industry our desires of what we want, but also to try to push the envelope a little bit. And so we're really looking at increasing power generation a couple of different ways. One is via the main generators. And then another is by converting the APUs essentially to SPUs, where we can use them in flight versus just on the ground or only during emergency conditions. And so longer term, we are, from a power generation standpoint, we are looking at moving to 270 volt DC, which would also include looking at bringing on things like starter generators for engines potentially. That would be at 270 volt DC. But again, that's all part of the overall architectural effort where we figure out, okay, what makes the most sense and what are the trades relative to these? Because I can tell you, if we were to try to go 270 volt generators today on the DC side, how do you even make that work for an enduring fleet platform that has so much 115 AC? The conversion for that just gets outrageous as far as weight goes, and so it becomes a non-starter from day one. So it's going to take an incremental approach to get us there, but we're seeing that there's some good potential means to do that. Next line item is power conversion electronics. In general, power conversion electronics are really no different than many of the other EPS systems that are on board. They're circa 50s to 70s time frame. They're heavy and have pretty poor efficiencies. Now, they had great efficiencies compared to when they were first built, but compared to electronics or power conversion electronics that we have today, it's nowhere near the same. Today we're looking at materials like silicon carbide that have been out there for a while, or even gallium nitride systems that offer substantial weight savings while providing even more capability and at very high efficiencies, which is good because we know as we continue to increase the power on the aircraft, our thermal loading goes way up, and so having those higher efficiencies helps offload some of that. We also have some pretty ancient circuit breaker technology on board, and so I think that's another area ripe for looking at again, and even having some weight savings with that. I'd say, in general, for more than a decade, the aviation community has been using digital circuit breaker systems that save a lot of weight and really enable a lot of flexibility when it comes to making changes on the aircraft from an electrical perspective. and being able to digitally interface with those and control those systems. Just it amazes me still today when, if you talk to some of the pilots out there that, they're used to knowing exactly where that one specific circuit breaker is behind their head or something, and they can just reach back and find that exact one, where, really we could take a lot of that workload off of them if we had a digital interface and even had some smart controls associated with them. Next item is one I'll spend a little bit more time on, maybe, is just power management. And we believe this is really going to be key to both the incremental approach, but also kind of the long-term approach, even for a future vertical lift, because there's a lot you can enable as far as increased capability on our platforms with some intelligent or smart management of these power systems. Historically, our systems have been rather dumb, I guess you could say. It's either the generator is running or it's not running. And if it fails, it will look for another source of power, but that's it. It's about all you have. Again, we have a 130-pound APU that has a significant amount of power generation capability, but again, it's only used on the ground and is essentially carried as dead weight for the remainder of the flight. We have emergency batteries that store energy, but are only used for emergency. Again, not real smart power management, but smart power management would say that we need to leverage all of these sources in a way that we can increase the overall capability at an aircraft level. So let me kind of run you through some of the benefits of these that you see over to the side of that chart there. One is automation, right? With today's technologies, we should easily be able to automate most of the electrical power system. The system knows how much power is available at any given time and can respond that way. It can turn systems on or off to meet whatever the demand is. In the event of future failures, it can smartly shut off aircraft systems instead of the crew trying to spend time during an emergency situation and trying to determine which and how much stuff to shut off. We can actually get more lift out of our aircraft by shutting down main generators. And so, for example, if a generator requires roughly 70 shaft horsepower to run at full capacity, then I'd like to be able to choose to run systems off a battery for a short period of time so that all the generators free spool and essentially give power back to the main rotor system. I can also do things like silent wait ops. One of our former APMs in this area, he was a Chinook pilot, and he said that he would frequently just sit on the ground in a Chinook with the APU running, purely so that they could have radios up and running, waiting on the call. And he said, sitting there, we're just burning fuel up, and it's super noisy, and you can't crew coordinate, and why can't we just have a battery that I can power those systems off of and actually have silent wait ops? So we think there's lots of those types of benefits that are out there for the taking, and we just need to spend some time to fully vet those and understand those and see what the trades are relative to them and choose to go execute against them. Now, next is the FEO aspect. You can't talk about anything in the Army today unless you talk about future vertical lift with it as well. So I'll talk about future vertical lift. We are highly integrated with the future vertical lift folks. I talk to those folks at least once a week, if not more, and we spend a lot of time with the FEO office providing them input on requirements and trying to understand how vendors are going to architect solutions that we can be prepared for the future. And again, we think that they're likely to head down the 270 volt DC path, which makes sense to us, but also certainly creates challenges relative to what we have going on within enduring fleets. But we're not afraid of any challenges. And then the last bullet there is because it is highly relative to electrical power systems in general and the overall architecture, is that we really are trying to spend some energy monitoring what industry is doing relative to hybrid and all electric propulsion systems. And so next slide. This will be the last slide. I'll camp out here a little bit longer maybe, and because all this is I don't have a lot of math to back up these statements or to say that this is absolutely the case, but this is kind of that let's just take a moment and dream for a second and think about what the future could look like. And so to do that, I put together this chart, and I'll just walk you through all the piece parts because there's certainly a lot on this chart. So previous slides really covered the main architectural elements of typical electrical power system, but this slide is again focused on the propulsion aspect of that and how hybrid and even all electric propulsion may fit in there. And so I'll kind of start up top there. You know, from a turbine engine perspective, the technology has certainly come a long ways over the years. And that's due to programs like the 8 program, which then resulted in ITE, and then also programs like FATE, all kinds of great S&T efforts that have gone on over the past many years to help progress things. And from a turbine engine perspective, I see the future continuing to advance relative to things like MOSA controls, right? Modular open systems approach controls, maybe even enabling some more common controls as we move more and more into digital interfaces and control mechanisms. Additive manufacturing is certainly starting to pop up a lot. It's already on ITEP, and we're just going to see that continue more and more. Variable speed power turbine, our friends at the Technology Development Directorate have partnered with industry on a couple of different efforts, and we're seeing some great results there that could be available to be integrated onto our current solution sets. If those folks like FEL or even our current platforms decide that that's what they need, even more advanced materials and composites, it's always a surprising area. You just never know what's coming, and all of a sudden something new pops up, and that would really benefit the engine and can make a difference. We can get lighter, we can get more strength out of it, whatever the case may be. And then also the cyber secure aspect of engines, I think that's going to continue to progress quite a bit over the future. But where we are today with turbine technologies is that we have long development cycles. We tend to build aircraft around a particular engine. And when we don't, we often have to significantly derate engines or use them in a less than ideal manner to make them work. We really don't leverage that much from the commercial tech side. Yeah, a lot of times we'll see that, yeah, this really originated on the commercial side, but we're still developing, we're still investing big dollars in development activities with respect to all aspects of turbine engine technology. And typically the result is commercial will gets more of the benefit from it because they take technology that we have and it eventually migrates over there as well. The costs for growth capability are very high. Many times they result in either a very hefty CIP program, which is component improvement program, or it's a whole new engine development. And so, of course, we're very reliant on fossil fuels as well. And so if you've been around Dr. Jetty at all, it's actually one of the very first questions ITEP gets every time we go to see him is, what are you guys doing about not being reliant on fossil fuels? He's asking the ITEP folks that. And it's a great question. We ought to have a plan for the future and what that looks like and becoming more fuel efficient. Not that I don't think we'll, no time in the near future we'll be going completely away from fossil fuels, but we ought to make, as some people say, we ought to stretch the capability of fossil fuels a bit further. So they're around, but we ought to still be looking at other options as well. But again, I think the bottom line there is the one big green marker there on the current state is that we absolutely provide world-class turbine technology, and I think that's a lot for PEO Aviation and the Army to really be proud of. But where do we go? Where should we go next? And I believe, and several folks in our office believe, that we really need to be looking more and more at hybrid and electric propulsion solutions because they have the potential to fairly radically change not only how we provide power to a platform, but also how we develop platform solutions. But before we get into that, let's ensure we understand the market, right? Again, in talking all through this, we constantly are trying to look at the market, see what the market's doing, see where industry is investing and what we can leverage. And that's been a big push from the Army is that we've got to figure out ways to get more capability out to the field in a more affordable manner. So I think this is a very ripe area for us to leverage what the commercial world is doing, because it's areas that we're not having to spend big dollars in. So let's take a quick look at it. So at least a decade ago, the commercial aviation world started really re-architecting aircraft, and somebody could probably correct me. No, that was 2 decades ago, but anyhow, it's occurred, and they're way ahead of us. That's kind of my point. And aircraft design has been focused more and more on electrical power systems and making those better on the aircraft. I mean, I just know from flying on some of those aircraft myself, whether whether it's Delta or whoever, I'm sitting there on the aircraft, and over the time, I'm grateful that we all now have TV screens to use, or we all now can plug our iPhones into an outlet on the bottom versus carrying around a charger. But that came at a cost to the aircraft. They had to increase their power capability, right? So that's been naturally occurring. But again, that movement really referred to as more electric aircraft. I believe it's done a great job of really setting the groundwork for a migration to more electric propulsion aircraft. And I see a little bit of a gap between that is what I think is going to enable them to bring on hybrid propulsion systems. I don't see that the Army has done a similar, more electric aircraft movement to get us architected in a way that will more easily adopt those systems. And again, I've learned probably most of my information relative to this from VFS. So again, thank you, VFS, for always being a conduit to educating us on what's happening out there. And so at the front of a lot of and so let's talk eVTOL real quick also, because that's obviously been a huge area for VFS as well. And I've enjoyed being at every event I can possibly be at relative to that, because it's just amazing what's occurring. And at the front of that is, we often hear from the folks like Uber Elevate or whatever, and you see they've got things like 200 companies working on concepts, and more than 12 of them have prototypes built, and that's probably double now. Who knows what the current number is? I'm sure somebody on here could tell me what that is, but it's just amazing that it's progressing that quickly. And whenever I start sharing some of these numbers with folks within the Army, they're blown away. They just weren't tracking it whatsoever. And it really starts to beg the question, well, if that's already out there, what are we doing? And as an Army, I don't know that we're doing that much relative to these areas, especially with your manned aircraft. So what does that future look like? Do we migrate in that direction or not? I don't know. I think we need to be open to thinking about it. I think we also need to be open to thinking about the trades relative to those. One of my, I guess, pet peeves all along has been as we go and develop something new, the common approach is, hey, let me take the spec from the previous aircraft, and that's our starting point. No, I mean, starting point is, hey, it's a good template. I mean, that's a starting point for, it's got to do this plus a whole bunch of other stuff. But I truly believe that things like hybrid and all-electric propulsion, that if we are willing to make trades, there are some significant benefits we could get from those systems. And so the question is really, so how will the Army respond to what industry is doing and how industry is investing into all of these areas? And maybe also the question is, and probably not for this forum, is how are our adversaries going to leverage those investments? And so, again, I believe that there is a strong case for us creating essentially a new propulsion baseline for our future aircraft by taking our world-class turbine engines and pairing them with hybrid technology. And so let me just kind of give you an example. If a new aircraft propulsion baseline was a turbine engine with a motor generator, electric motor generator, then that presents a significant ability to achieve growth and be flexible in meeting new aircraft configurations. And so let's just say, here very soon we're going to have a 3,000 shaft horsepower engine available. Let's pair that with a 200 kVA motor generator that can surge up to 300 kVA, so roughly 250 shaft horsepower surge. Now, what does that baseline enable us to do? And so let me give you a couple points on that. It enables me to pick a turbine engine more based off of normal operation of the aircraft versus corner cases. The E motor can enable you to hit those corner cases. And this also provides the ability to keep the engine running at a more constant speed throughout the entire flight versus just in certain parts of the flight, which, doing that, being at that more preferred speed enables us to have better fuel efficiency and have better lives on our components. It enables me to charge energy storage systems during more benign modes of flight. It provides additional redundancies for the propulsion system. And it also offers multiple growth paths. So you can still continue to leverage things like Sipe efforts on the turbine side, but now also have the opportunity to do upgrades and get additional capability by upgrading the E-motor side of it as well, without having a major requal effort or a major development integration effort. And so things is like batteries get more energy dense, we can more easily just swap them out and get more capability on the aircraft. Same goes for generators. They continue to become much, much more power dense. And so we can get a lot of capability out of very little change in the size and weight of those systems, without a lot of requal effort in comparison to what we would see on a turbine engine side of the house, where if you make a little bit of a change, you're going to be paying a lot for a requal effort and having to do a lot of flight test activity. And you can do all this in a very quick manner, right? So what does this get us from an airframe side? Now we have many options on the propulsion side to meet propulsion requirements of any configuration, right? It gives me much more flexibility, so I'm not having to do what I referred to earlier as, and we'll put this giant engine on there and then we'll derate it, because that's all that is available. Right now it gives me more flexibility to adapt to that. Which also really opens the door for us being able to look at emerging threats and the needs of things like MDO or the JADO environment, and gives aviation the ability to rapidly respond with new airframe configurations to meet those specific missions. And we get all these done at hopefully reduced costs, because our ability to leverage the commercial sector is really the ability to leverage the commercial sector, because they are so far ahead of us with respect to all this. So do I believe we'll have a new propulsion baseline? I don't know, but again, the point of this chart is to open our minds to it and be thinking about it. And if it makes sense, then I think we ought to think about moving in that direction, because I think there is a potential for a significant capability increase by doing something like this. And so with that said, I'll pause for any questions.
Okay, Matt. So we've only, I'm looking at the chat and question window. I've only had one question in there. Let me reiterate it for the audience. Let me pull it up here. Hold on a second. Okay, and the question comes from Dr. Schrage. It's good to see you, sir. Dr. Schrage was my master's professor at Georgia Tech. He's asking about how is hydroelectric power being utilized on Sikorsky's FAR prop. So maybe I'll ask it in a different way, Matt. You kind of touched on it a little bit. I want to stay out of the competitive, sensitive environment that the FAR CP aircraft are under. You talked a little bit about surge requirements and how you might be able to use turbine engines in a more predictable and regular way to save on fuel and costs, and use the hybrids to deal with these corner cases that you speak of. When I think, a propulsor on a compound aircraft and a dash speed, I think of that as one of those kind of cases. How do I get to 280 knots, say? Or how do I hover at max gross weight, at 4K 95? Do you see the PEO PM specs moving in a way to be able to take advantage of those kind of configurations to answer the mail when it comes to that kind of requirement?
Yes, I certainly want to be careful in my response to that relative to those efforts that are actively going on.
But yeah, if we could talk more in terms of how do you take advantage when you build a spec to address these corner cases, right?
Yeah. So I believe it's a couple of things. Certainly on both of the FAL platforms, the government's goal is to really give industry space to innovate. But I think we also all realize that while we've been trying to give space to innovate, when you put something like extreme schedule pressure on a group of folks, that can also do the opposite. That can reduce innovation. So I think part of it is just the PEO sending a clear message as what's not necessarily what's acceptable, but we're interested in hearing about those other options and what they may bring, and if they are for the initial increment, maybe that's great. If they're for a future increment, that's great. I can tell you, and so I can't speak for those program officers far and far, but I can tell you from our office perspective, we're very interested to hear about those kinds of ideas and whether you think they buy themselves onto the platform and when and how that might look. We're interested in hearing those things. And so I'm not asking for those vendors to come see me and try to get me to go advocate for them. I'm just saying from a technology perspective, we want to hear about that and because ultimately we need to be able to make a business case that, yes, we need to push industry in this direction. And right now, I just don't think we quite have all that data. There's, just like my last chart here, there's a lot of brainstorming that I did, right? It's not backed up by a whole bunch of modeling, which is kind of another effort that I've got going on the side with ARLs. We're doing some hybrid propulsion modeling with them to try to look at some of these configurations and see, okay, at what point does it make sense to migrate to some of these, right? So we can better inform those specs and encourage those things to be part of the configuration.
Okay, so we've got a question along the lines of that making sense. So when that migration might occur, from Joseph Prisinger. It says, hi, given lithium-ion batteries have an energy density of 0.7 megajoule per kilogram and jet fuel has a density of 45 megajoule per kilogram, how good is a trade-off to take weight from fuel to batteries? And how reasonable is it to leave the fossil fuel?
Yeah, no, that's a great question, and it's a question we're certainly struggling with trying to answer and trying to project, because you don't know where battery technology or other forms of energy storage are going to be in the next 5 to 10 years. But my big push on this has really always been, yes, I agree. The energy storage technology that we have today, it would be very hard to make the case. Very, very hard. And I think it's almost impossible to make the case. But my point is a lot of these systems don't fill for another 10 years. And so I think what we need to do is try to take a best guess at where we think these things are going to be in 10 to 15 years and plan on those systems being part of the configuration. And of course, understand the risk of those if they don't meet those higher densities. But to his point, I don't think you're ever going to find a energy storage system that is going to be as dense as the same weight of fuel. So I think all electric propulsion, that's probably a separate category of aircraft. But I do think there are going to be some scenarios where hybrid propulsion will make sense, especially given the ability to be able to recharge a pound of battery and you can't recharge a pound of gas.
You'd be pretty rich guy, I think, if you could recharge a pound of gas, Matt. So work that out. Yep. Okay. So here's a question on what's historically was the motivation for lower voltage systems on rotorcraft. Do you know the background there, Matt?
I don't think I do, unless it was something tied just to the safety aspect of it. That'd be my only guess. I mean, I know with our current systems we have today, we have plenty of people still shocking themselves regularly.
Yeah, I don't know the background there either. Okay, we got a number of questions on more detailed level. Jennifer Gruce asks, are you also considering next gen wiring requirements, and what are your views and concerns at this point regarding wiring?
Yeah, so that's a tough area, even before considering next gen stuff. It's even current generator wiring. If you just look at 270 volt configuration aircraft versus what we have on the aircraft today, that's a different wiring schema. And so that's certainly a struggle of trying to figure out how do we migrate the higher voltage systems with the enduring fleet without having to rip out all the wiring. And because a lot of your benefits do come from having to have reduced wiring sizes when you go to some of the higher voltages. So yeah, certainly a complex problem. Certainly, and again, I'll tell you, our team, when I say we have a team, we have a couple guys that have been working this, and they weren't experts in the area, but they're quickly becoming experts and trying to find all the experts out there and have these discussions so that we're not making architectural decisions or requirements related decisions without getting input from industry. And so part of that is we actually sent out a RFI, I think it was earlier this year or maybe it was last year, that basically went out to all of industry and basically put out there, here's all the architectures we're thinking about. Tell us what you think about these architectures for the enduring fleet. Tell us what you would change. What's the alternate architecture you would pitch? And so we've been very open with industry in trying to understand the space and let them help influence where we head.
Yeah, I know from my experience, even estimating wire weight in the system is becoming more and more difficult. It's taking a larger and larger percentage as everything now wants to be connected to everything else.
Right.
Okay, I got a question here on capacitors. Are you seeing any need for high temperature, high voltage capacitors in future electrical power systems? From Jeff Woods.
Ooh, I'd probably have to pass on that question. I want to say yes, from what I remember our guys briefing us, that there were certainly scenarios there that would make sense, that's a focus area. And again, this probably goes for everybody. I don't know, Bill, if you've sent this out already, but certainly feel free to send out my contact info. I'm probably going to be forwarding most questions to my tech team that's been working this, but I think we may have addressed that during our RFI.
Okay. All right, that's the list I have in the question section. Let's see if there's anything else in the chat here. Okay. Does anyone else have any other questions from the audience or from the field? Did we do a good job answering those that you did ask? Here. I had a hand come up from John Piasecki. I'm gonna. Do you have a question? I'm gonna unmute you, John, for 1 second. John, can you hear me?
Yeah, I can hear you. Thanks so much. I appreciate it. Great presentation. I'm just thinking about the opportunities where we might have an to spiral in technology into the enduring fleet and FEL. What are the timelines that might coincide with those kind of opportunities, Matt? Are they, the ITAP is going into the H-60 and the Apache fleets relatively soon, isn't it?
Yes, that is correct. And I tell you, in general, we don't have really solidified dates for, hey, here's the hard date. But if you really look at that kind of FY 26 to 28 time frame, it seems like there's a lot of things occurring right in that timeline. And so, again, if it's something where we're going to be a little bit disruptive to the platform, as far as, hey, that it's not just a simple MWO. It's hey, this may have the aircraft down for a period of time. That's the kind of time frame you'd want to get in and kind of marry it up with maybe an ITAP integration or one of their other recap efforts or something like that, so that you're not, having the aircraft down multiple times every couple of years.
Right.
All right, thanks, John. You got anybody else? I can see the hand raising. If somebody's got a quick question, they don't need to type it or want it. You mentioned ITE. To me, Matt, one of the big challenges is answering the mail for all those platforms, right? Black Hawk, Apache, and FEL now, and everyone's got the mandate to do this a lot faster and for a lot cheaper. So to me, that's a super tough challenge to be able to balance those demanding customers.
Certainly agree, it is challenging.
Okay, I'm not seeing any other questions. Okay, on behalf of VFS, certainly, Matt, thank you for your time with us today. I know we've seen you a bunch at the forums and everything else, and for your continued involvement here with the society. Certainly, if there's something the Redstone chapter can do, let us know. And then, as always, we're always looking for feedback from the audience. So feel free to send me an email directly, or just send one up towards National, and let us know how we can do this better and get this done more often. I think these virtual type forums are here to stay. I think we reach a large audience and can get a lot of good information out in a productive way. So thank you all for your time. Matt, do you have any closing remarks you'd like to make, or anything else from Colton?
I think I'm all good, Bill. I can just appreciate the opportunity.
Yeah, same here. I really appreciate you having us there, and yeah, look forward to the next one.
Yep. So we'll see notes out in November for something out of the Northeast. And again, thanks for your time with us today, and thanks for supporting VFS. So we're going to sign off here. Thank you.